Hello everyone, welcome back to Linked Frequency. In this tutorial, we are going to learn about how to create an automatic plant watering system using a soil moisture sensor. This is the 12th tutorial of practice project for PCB designer, and I'm Vaibhav Sugandhi, passionate PCB designer and technology startup founder. This video is focusing on utilizing the concept of soil moisture sensor that we have designed in our one of the previous tutorial. And we understood how exactly that soil moisture sensor is behaving with respect to the operational amplifier being used inside. And using that particular sensor and a development board called Arduino Nano development board, we are going to integrate them to create an application called automatic plant watering system. This is going to be an application level design activity, which is kind of a beginner level only, not so complicated to call it as an intermediate level. But you must understand these kind of products are available in the market. If you understand how to create applications by using the development boards or the sensors that we have designed previously, then that is the advanced version of your PCB designing course. So let's start with the black box analysis for this particular project. The first thing is we have a black box analysis. In this particular black box analysis, we are considering the lithium-ion battery pack as the source of power for us. Again, do remember we can use the external power source, that is all about AC to DC converter. But again, we can use the lithium-ion battery pack. Why? Because it is going to be a portable wherever there is a plant and wherever there is a plant to be powered with the AC cord and all, it will be a very complicated one. That's why we are going to use the lithium-ion battery pack so that we can make this entire device as a portable one. And of course, whenever we use a battery pack, we need to have a battery monitoring circuit so that we can recognize how much battery power left in the entire circuit or maybe the battery pack, and then charge it on time when it is not draining below the 20% of the charge left in the battery voltage. Then we will be having a DC power supply circuit which converts the battery pack voltage into a regulated DC voltage so that our entire microcontroller circuit and the sensor circuit should work properly. Thereafter, we will be having a main controlling unit with a USB programming and a debugging, which is Arduino Nano development board at this point of time, as we already discussed in the title slide. And then after, we will be having a soil moisture sensor and a DC water pump so that we can control when to water and when to not water the entire plant. And then user defined or user interface devices, for example some of the indication circuit or maybe a buzzer or LED, something like that. So now let's jump into the white box analysis. This is how white box analysis looks like. We will be having a 8.4 volt 2 series lithium-ion battery pack. Why we need a 2 series and why we need 8.4 volt? Of course, if we use 3.7 volt, then it is not sufficient to power on our development board, neither our water pump. That's why we are going to use a 8.4 volt 2 series lithium-ion battery pack, and we will be using a voltage monitoring sensor to monitor how much power left in that entire battery pack. Then we will be using a LM7805 regulator, a linear voltage regulator, to convert 8.4 volt or approximately 8.4 volt battery pack voltage into a 7805's output, which is a plus 5 volt DC. And then that voltage is given to the entire electronic circuit to function as our requirement. This is the simple white box analysis. Again, before to this white box analysis, morphological chart and the datasheet analysis is mandatory, as we already mentioned in our first and second tutorial of this entire tutorial series. Now I'll show you some secret of the EasyEDA tool. I call it as a secret. Yes, I'm saying it right way. Secret only. Why? Because most of the design and development activity requires this secret to be implemented all the time. Then only you can increase the speed at which you develop the design activities. For example, you're doing one project like this today, and tomorrow you may be having one more project like this. In the entire month, you have a 30 to 40 project to be completed. On that time, if you continue to design your circuit one by one, it will not be possible for you to complete all your 30 circuits in 1 month. That's why we will be revealing one small secret to you in entire EasyEDA software. I think it is similarly available for the other software, other EDA tools as well. But right now I'm focusing on the EasyEDA. So let's talk about that particular secret. First thing is I'm going to go to file and create a new project here. I'll name it as a automatic plant watering system. Alright, so I hope I have given a proper spelling for everything. No, actually. So plant watering system, right? Yeah. I'll click on the save and project will be created and schematic sheet will be generated automatically. I will change the name to schematics and then I'll change the title to, and now we are good to go for the further steps. So here we have a secret. First thing is, we know we need to use a 8.4 volt lithium-ion battery pack, and along with that there should be a power supply. Do you remember something? In our one of the previous tutorial, we have done this part of the circuit exactly the same way how we are using right now. So why can't we use that particular repository? I think that repository may be something inside these project only. Let me check for them. I think it is a Max 30100 with Arduino circuit. That one is all about the battery pack and all, right? So we have a power supply here, and this power supply is exactly what we want right now. So I'll just copy it. I'll select the entire power supply, and now you can notice that the reason why we create these dotted border and give a name to that particular section of the circuit, this one looks very funny at the time of when you started learning, but right now you can recognize the value of that, right? So I'm going to select that and copy it and come to my particular schematic right now that we are designing, and voila, you just place it like Control V, copy and paste, and you are done with your circuit. Yeah, it is a very funny thing, but this will reduce a lot of effort for the designer to start with. Okay, so that's amazing tool, and that's amazing secret of the entire Arduino, not Arduino, the entire EDA tool that I'm using, that is EasyEDA, and it saves a lot of time for the designer like us. Okay, and the second thing what we need is the voltage monitoring sensor. So that voltage monitoring sensor is also developed in that particular project. So I'll just copy it and come back to our circuit and paste it here. This looks like some secret thing which will complete your assignments very quickly. That's amazing actually. Okay, and also we need Arduino Nano development board. So I'll just copy that particular part as well. Again, it's not so complicated, which will necessarily need to be copied from some other project, but still I'll do that particular thing at this point of time. And thereafter what we have is soil moisture sensor. Again, the soil moisture sensor is one of our previous project. So I'll go to that particular schematic, a soil moisture sensor schematic. Here you can see that this entire circuit is all about soil moisture sensor. Notice I'm not copy pasting the connector part because we don't need a connector. We need the entire sensor right now. So what I will do is I'll go to our particular project and I will paste the entire circuit. Here you can notice that VCC is here and we have a +5 volt here. So this is the important thing. Just copy pasting is not a skill actually. It is just a knowledge that I have given to you. Now you need to understand that knowledge and implement it as per the required technicalities. So now our power supply is having a +5 volt symbol here, which is a power symbol in our entire circuitry. And if I go to the Arduino Nano development board also, we have a +5 volt. So that's why it is matching and the power connection happens properly. VBAT is a different story. So VBAT is connected to the sensor of battery monitoring sensor unit. So that is absolutely right one and it is going properly. Now this +5 volt should be provided to the soil moisture sensor. So what we need to do is we need to change this entire VCC symbol to the +5 volt. So how do we do that? One thing is by double clicking on that, just we can change the text like this. Another thing is by replacing it with this particular symbol. Whichever you feel comfortable, you can do that. None of them are right or wrong in that case. Okay. Just make sure that you are writing the same text as given here, +5 volt. If you write only 5 volt, it doesn't connect actually. It doesn't make any connection between this point and that point. So I'll just change it to the +5 volt everywhere. All right. So this is how we are done with our soil moisture sensor. Notice here the soil moisture sensor is also having a power indicator. And if you are having a power indicator here, it doesn't make any sense to create that same power indicator one more time. So I'll just delete that part of the circuit as well. While copying only, I would have copied only this much of a circuit, but again, no problem. You can delete that as well. So this is how you need to understand which one to copy and which one not to copy. Even after copying also, you need to understand how to utilize that copied content to suitabilize your entire requirement. So now I'll change it to the soil moisture sensor. All right. So that is how the border is created. And I'll keep this circuit somewhere here only, just for the sake of simplicity right now. I'll go back to our block diagram to understand. We need a 5 volt DC water pump and RGB LED and buzzer. So these things are not done previously in our entire tutorial series. I have done it in a lot of project of 150 or 200 project that I have done previously. But right now, I'll create it one more time. First, I will go with the water pump. Water pump design has to be done with the very important thing, that is all about MOSFET as a switch. I hope we have used a MOSFET as a switch in any of our project, but right now I'll not copy it one. I'll go and select the MOSFET here, maybe IRF 540, that is N channel MOSFET. IRF 540 is an N channel enhancement type MOSFET, I guess, but I'm not sure which one it is. But I'll just copy the IRF 540 here. I mean, I'll take the IRF 540 MOSFET. It is an N channel MOSFET, so I'll keep it here. And we will be using a 2-pin RMC connector to connect the this one 2-pin connector here. Our water pump has to be connected with the circuit by using a 2-pin RMC connector. So I'll name it as a RMC underscore 2P underscore 2.54. Okay, by just renaming this one, it will not be updated with a 2-pin RMC connector. We have to literally select it and change the footprint to RMC underscore 2P. I hope we'll get that 2.54. Yes, absolutely. This is how we need to change the footprint of the connector to make it as a RMC connector. And since it is a water pump, we need a diode for that as well. It's a freewheeling diode. So 1N4007 is the freewheeling diode that we are going to use. I'll just select that one as well and place it in the middle here. Place the text properly and take it a little above. And here we have 2-pin and connecting it here. Just to make sure that it is connected properly, I'm taking care of the connectors here and here. So we have a +5 volt in the entire system. So I'm going to connect a +5 volt here. And then this side, we need to connect a ground plane directly. So before connecting a ground plane, of course, we need resistors for the controlling, right? So I'll be using this resistor here. I'll be placing this resistor here and one more resistor to this place. +5 volt directly. Oh, okay, it's an N channel MOSFET, so it should be connected in the bottom side, not on the top side. P channel MOSFET should be connected on the top side. So I'll just take a ground plane a little bit down, and here you can go that. So this one goes to this place, and this one is a gate to source resistance, which is always in the form of 10 kilo ohm, and this one is going to be 2.2 kilo ohm. And we are done with the water pump actually. So I'll name it as a pump, and I'll connect this one to the resistance. This is our water pump circuit. So I'll just copy paste the text here and name it as yes, this is all about our water pump. And after that we have a RGB LED and a buzzer. So let me create a RGB LED and buzzer. So for RGB LED we need a 3 resistor. So I will take 3 resistors here. I will arrange their name and value to 560 ohm properly like this. So these are the RGB LED. Now I'll bring a RGB LED directly, a 10 millimeter diameter of RGB LED. So I'll just say RGB LED. Let's see what appears in our search result. LED RGB. This is the SMD one. So we don't need that actually. We don't need SMD one, so we need a through hole. I think probably we'll go to the user contributed, because this RGB LED is more popular in user contributed. 5mm actually. Yeah, you can see that. This is a 5mm RGB LED that is available on user contributed section. So I think it is in black color. So is there any way we can get it in the colorway? I'm not sure. So let's try if it is possible. RGB is written over there. So that can be a sufficient one. So I'll just use this one because yeah, it's written already. So that's why we'll use the one which is available directly. So I will place the RGB LED here. This is a 5mm RGB LED. I'll name it as a LED 1. Okay. And a plus symbol indicates the VCC connection. It's a common anode type RGB LED. I hope while you are soldering, you will solder the common anode type RGB LED only. And I will be connecting these resistor to this LED as per the connection. And thereafter, we will be having a port connectors just in case we need, not in case, we need that actually. So this is a R LED and this one is a G LED. And then this one is a B LED, blue color LED, right? So B LED. So this is how our circuit looks like for the RGB LED. And thereafter, I think I'll remove this name so that it will be reduced in size a little bit. A kind of a good design, looks like a compact design, but naturally it does not necessarily need to be done in that way. Now we have done a lot of circuit, lot of the part of the entire circuit is done. Only part is left is a buzzer one. So now we have a two ways to create a buzzer circuit. One way is using a transistor to drive the buzzer, the way how this water pump is driven, or maybe this particular voltage divider circuit has driven. This is a one proper way, and that is the most recommended way in the industry to drive the buzzer from any type of microcontroller or maybe a development board. But again, in this particular circuit, to make it simple, and already there are a lot of circuit already implemented in this part of the design, that's why I will make it easy and I'll go with the direct connection of buzzer actually with our Arduino Nano development board. So I'll type a buzzer here. Let me see if I can get a good buzzer circuit here. I think yes, we have one buzzer here. I think this is a right one. If I'm not wrong, a 12 mm buzzer is what we are looking actually. So 12 mm buzzer is the right component to select for our requirement right now. So I'll place it here and I'll rename it as buzz. So this is a passive buzzer, and this buzzer is normally used for all the DIY projects. So let's go into that. One part of the buzzer will be connected to the ground. So I'll just connect the negative part of the buzzer to the ground, and one more part should be connected to the buzz. So I'll just make it as a buzzer, and I will connect it to this particular thing. No resistor is required. Nothing else is required. Of course, a transistor driving is always a better one. But right now, I don't think so. We need to make a transistor driving. Already circuit is complicated. So we'll make it easy for you to understand at the beginner level. So those who are already having a lot of experience with respect to hardware design engineering, then obviously go ahead and create a transistor based buzzer circuit. Okay. A transistor driving circuit for the buzzer. Okay. This is all about our circuit. Now we will arrange them in a proper way so that we can make it a better looking circuit diagram, right? And we are done actually. So I'll just take the entire circuit a little bit downside so that we can match it with this particular part of the circuit. And then we will reduce the height a little bit, maybe 800, I guess. No, not 800, 750. 750 too less, but let's try. 850 for the width. Width 850 looks good, and height 750 also looks good to me. So just I'll select the entire circuit, make it a little bit downside so that on the top side it is matching, and in the inside that is also matching. Not an issue. That's a good thing actually. So now I will make it a fit to screen. This is how the circuit looks like. So alright guys, now you understood a detailed explanation about how exactly the schematic is designed. The most important thing in this particular tutorial is learning how to copy paste or how to utilize the circuit that you have developed in the previous tutorial. For example, Max 30100 module, that heartbeat monitoring sensor project, and also the soil moisture sensor. So we literally utilized the circuit that we have done in that particular project in this particular project. Now I'll just go with the PCB layout design as we already do with the way of fast forwarding. Alright, after a lot of effort and lot of creative work, this project is completed. Again, this is a 2-layer board and single-sided with only through-hole component. No SMD component is being used in this entire project. But one thing very important we need to notice is this is a 2-layer board, and this board, I think this kind of a design is first time even I tried actually. While doing this tutorial only, I tried something new just to make sure that it is creative enough for this entire tutorial. And of course, it is based on the IPC standard. It is not just a guesswork without following the industry standard, not like that. It is absolutely following the industry standard and absolutely the professional way how we do in our company. The same thing that I have showed in this particular project. What is that? The thing is integrating a soil moisture sensor inside your main PCB only. Usually what happens, the soil moisture sensor comes a different one like this way, and you integrate the small module of this soil moisture sensor along with your main development board. But in this case, what I have done is I have integrated this soil moisture sensor with your main PCB only. This is something like, this is how it looks like. It's no more 2 PCBs actually. It is a single PCB. There are certain advantages to this one and there are some disadvantages to this one. Let's talk about the advantages first of all. The first advantage is you have only one PCB for manufacturing. There is no need to procure the couple of PCBs like a soil moisture sensor and its amplifier circuit and then your main development board. Not necessarily. It is only one PCB. The disadvantage part is the CNC machine which cut this PCB in the shape of our design will cost you a lot of money when you are going for a mass production. Maybe when you go for a very huge number of production, probably that cost will be very negligible. But at the point of time when you are designing this particular product for a DIY purpose or a small scale production, on that time this will cost you some money. Whether it is a costly or a cheap is based on how you are manufacturing and where you are manufacturing. So this is the entire project of soil moisture sensor based automatic plant watering system, right? So this is how the 2D diagram looks like. You can see it on the bottom side. This is how it looks like. On the top side, this is how it looks like. And you can see that this copper is exposed and it should be exposed. If it is not exposed, then it doesn't make any sense actually. You can see here, this part of the copper is exposed and tinned actually. This is called a tinning layer actually. So you have to make sure that this copper is exposed and it is tinned by a tinning method in the industry. HIL process it is called actually. So this is how the entire 3D model looks like, and it looks literally like a product to me actually. I mean, it looks so beautiful and we can literally plan for selling this product in real-time market. I think I have forgot to add our company name and the product name on this entire project. So let me add it here. Alright, so this is all about our project, automatic plant watering system or a circuit based on Arduino Nano development board and a soil moisture sensor. This is absolutely a complex one. I'm not expecting you to do it in a one attempt as you are a beginner. If you are an experienced person, of course you will do it in a faster way. And if you're not an experienced person, just don't worry. Give a try with this black box, white box, and then go ahead with this schematic diagram. Until schematic, you are very good actually because it is straightforward. But when it comes to PCB designing, you take your own creativity into account and try to make it in a different way. If you are not able to create this exactly how I did it, if you can make it, this is possible. Actually, it is possible for a beginners as well. It's not such a big thing. If you can do it in your second attempt also, that's a great thing actually. If you can do it, just let me know in the comment section. I'm very happy to hear about your experience while designing such kind of a unique PCBs with a unique shape. Okay, and when you go to the 3D model and all, you can visualize it in a best way like this one. And of course, it is a proud moment for a PCB designers while they are learning. So I hope you enjoyed this entire tutorial, and I believe you have learned something new and very creative activity with respect to PCB designing in our tutorial. Thank you so much for watching. Consider subscribing to our channel Linked Frequency. Ask your questions in the comment section. I'm more than happy to answer your question at any point of time. See you again in the next video. Until then, tune yourself to make a difference.